Perimeter and area. Perimeter is the distance around. Or the sum of the sides. And area, if you look at it like this, is the measure of the region within the boundaries of the figure, whatever that means. Area is the amount of stuff you can put on a two-sided figure. How's that? It involves putting stuff on a flat figure. To give you an example, right quickly, rectangle. The area of this, or the perimeter, will be this side plus that side plus that side plus that side. The area would be all that in there. That's the difference. So we have formulas here, and I typically don't use formulas for perimeter, but if you want to, you can. And we'll look at the shapes. Probably better to look at the shapes than look at this chart, so you can see how they look. For a triangle, you just add 3 sides. It doesn't matter. Side 1, side 2, side 3, if you ever see that. For a square, you can take side plus side plus side plus side, or 4s. That's the same thing. If that for a rectangle, the opposite sides are the same. So if that side is L, this side is going to be L. If that side is W, that side is W. You just add up the 4 sides, or use that formula. Parallelogram, if that side is B, which is called the base, that side is also the base. If that side is W, this side is W. So you just add up those 4, or do 2B plus 2W. For a trapezoid, you have 2 bases. It actually consists of 2 triangles. So for a trapezoid, you do add this side and this side, which are the 2 bases, and then add these 2 sides, which are the 2 lateral sides. Now the area is a bit more interesting. For a triangle, it's actually half of a rectangle, if you want, or half of a parallelogram, however you want to look at it, or half of a square. So if you think of area as being 2-dimensional, side times side, so for a square, side times side is the same as side squared. For a rectangle, length times width is LW. Then for a triangle, you got 3 sides, and it's not as easy to do. It's actually side times side. In this case, base times the height, and then half of that. Then parallelogram is the same as a rectangle, more or less. Base times height. It's the height times the base. And for a rectangle, the height is actually the width. And then a trapezoid, it's 1/2 times the height, and then times B1 plus B2. You're actually cutting this up into 2 triangles, is what you're really and truly doing. Kind of like that. This is triangle 1 with the same height as this triangle. See that? That's a height. And this is the second triangle. So, main thing is knowing how to recognize these shapes and when to use them. Formulas will probably be given to you some way or another. So let's do a couple of examples. This is a triangle. We're going to find the area of this triangle. So the formula for the area of a triangle is 1/2 base times height. Well, this bottom part is called the base. And then this 20 is going to be the height, because it represents that part right there, this line. That number has nothing to do with the area. So all we're going to do is take our base, which is 38, and our height, which is 20, and substitute them in. And we're going to find the answer to this. However you want to do it, does not matter to me. To me, if you want to do it by hand, you take 1/2 of 20, which is 10, and 10 times 38 is 380. Since this is area, you're taking centimeters times centimeters. It's going to be centimeters squared, or square centimeters. If you want to use a calculator to do this, that's fine also. 1 divided by 2 times 38 times 20. 380. That just went left or right, just as it was. Perimeter. I don't care what the shape of this is. Even though it's a parallelogram, I know that if 8.6 meters is the length of this side, then this side is also 8.6 meters. Let me erase that. It looks kind of strange. And this side is 7.6 meters, and this side is also 7.6 meters. So what that means is, all I'm going to do is, to find the perimeter, P does stand for perimeter, A does stand for area. I'm going to take those 4 sides, 8.6 plus 7.6 plus 8 8.6 plus 7.6 and add them together. You could easily take 2 times 8.6, 2 times 7.6 and add those two together. It is totally up to you how you approach this problem. Does not make a difference to me. But I'm going to take out a calculator. 8.6 plus 7.6. I could add those two and then times that answer by 2 if I wanted to. Plus 8.6 plus 7.6. Probably going to get, let me see, 15, 16.2, 32.4. What do you know? And this is perimeter, which means it's a single dimension, because I'm adding one side at a time. I'm not multiplying anything together, so the units stay as meters. For area, the units are always squared. So like the way I like to word this is area has squared units. Squared units. That is just horrible handwriting, so I'm going to rewrite it. I could type it. Just type it, you want to? Can't hurt. Squared units. And then perimeter, I just like to say single units. Something like that. Single for perimeter, squared for area. That just gives you an idea of how to work some area and perimeter problems. Here's a problem, a word problem. We have a lacrosse field. One pallet of sod covers, it costs $360 and covers 480 square feet. As soon as you see that right there, you know what comes to mind? Area. That's plus when it says area of a rectangle with a length of 360 feet and a width of 228 feet. We want to determine the area. So everything is telling you area. We want to know how many pallets are needed and what the cost would be. So the first thing we need to find area. Find area of field. So the way we do that is we're going to use a area of a rectangle formula. Area equals length times width. And the length is given to be 360 feet. And the width is given to be 228 feet. So what we're going to do is take out our calculator for sure this time. 360 times 228. And we get 82,080 feet. Square feet, I should say. Square feet. And keep that there. Now, so we've got the area. Now we need to know how many pallets are needed. Well, one pallet covers 480 square feet. So how do you find the number of pallets? It's a number sign. Number of pallets. It's found by taking the total number of square feet of the field, which is 82,080, and divide that by 480, because that's for each pallet. So I got my 82,080. I'm going to divide that by 480, and we get 171 pallets. Now, if I got something like 171.1, 171 won't be enough. I have to use 172 pallets then. You can't buy 0.1 of a pallet, is the assumption. So that's the number of pallets. And then what's the cost? Well, how much does it cost per pallet? $360 is per pallet. So we take 171 pallets, and each of those is $360. So 171 times $360 gives us a grand total of $61,560. There you go. So we found the area of the whole field to be covered. We divided that by 480 square feet because that's how much one pallet covers. So that means there's 171 pallets. And each pallet costs $360, so we times that by 360. We get a grand total of the cost of the sod to be purchased. So you break it down one piece at a time. That's how you do those kinds of problems. Circle, buddy. Circle, you have a point in the middle, and it's the same distance throughout. Everywhere you go from that center. So that point in the middle is called the center. I use a C for center. C for center. So it's the distance from center to the outside edge of the circle is the same. That's why it's called a circle. Half the distance across is called the radius. And that's the fixed distance, by the way. The diameter is all the way across. So all the way across the diameter. So if I were to extend it all the way down, this would be another R. So if you take R plus R, you get the diameter. R plus R is the same as 2R. So the diameter is the same as twice the radius. And the distance around, that's a great looking circle I just drew. That's called circumference. So it's like the perimeter. Now, I can't add up the sides of a circle because the circle has no sides. So that means there's going to be something strange that might pop up. And that's something that's strange is called pi. Pi is found, pi by definition is the ratio of the circumference to the diameter. The reason why it is because see that C equals 2 pi r. And there's another formula you can use. See that 2 pi r is the same as 2r pi. And what is 2r the same thing as? It's the same as d. So you can write that as pi d if you want to. Totally your choice. I think it's safer to always use the r because the area always has the r. The reason why we have a pi is because it is the ratio of the circumference to the diameter. Its decimal never ends, never repeats. One way to think that is a circle actually never ends or repeats. If you want to see it on a calculator, most of them have a symbol that looks like that. And it's a big old decimal that never ends, never repeats. A lot of people use 3.14. So if you're ever told to use 3.14, that's what you'll use. And if you're not, you'll use the pi symbol on your key or the pi symbol on your calculator. If you have a graphing calculator, this one's 84. It's a where's it at? It's above this symbol. This is the exponent key, so above that, which is blue in this case. So I'm gonna hit the blue key first, and then that key, the hotstop key, the caret key, to bring up the pi, and then hit enter, and it brings up those digits. So that's where it's found on your calculator. This is how it's used, or where it's used with circles. It's used with circumference and with area. And we're just going to do a couple of examples. We're going to find circumference, and I'm going to use C equals 2 pi r. What we need r. We're given d is equal to 18 yards. So r is half of d, or d over 2, or 18 over 2. Or 9 yards. So once we have that, we're going to replace the r with what it is, which is 9 yards. And then I'm going to take the 2 times the 9 because I can multiply those kind of quickly. I don't know what that thing is I just drew. And then bring the pi symbol down. I'm going to put that in parentheses, just so you notice it's different from the units, which are yards. And if I wanted to use a decimal approximation, I can take out my calculator and type in 18 times pi equals, and we get something like 56.55 if I go 2 decimal places. yards. And that squiggly means approximately. If I use a graphing calculator, I can just type in 18 second caret and get that. Not too bad. We're going to find the area. We're going to use this formula. This is a formula for the area of a triangle, pi r squared. So use pi as pi for now. And then r is 2.85. And then the r is squared, so don't lose those units. Or that square, I mean the exponent. Miles, I can put that in there if I need to. By the way, whether or not I use the decimal approximation or the exact answer, the 18 pi is called the exact answer. This is an approximation. Depending on what I use, it will be based on what the problem asks for. So for this one, if I want the exact answer, I'm going to use my graphing calculator. I'm going to type in 2.85. This is the x squared key. It's a square key, or I could use that and then a 2. I'm just going to use that and then enter, and I get 8.1225 pi. Since this is the area, my units are squared. Now, if I want an approximate answer, I will take the 8.1225 and times that by my pi. Now that ANS is 8.1225 for using this common calculator. And we get 25.52 square miles. If you're using scientific, I'll do this. I'm just going to start from scratch. 2.85, this has a square key. I'm going to times that by my pi. And we still get 25.52 if I round off. There you go. Circles. Not too bad. Now here's a better example. Determine the shaded area. That means we want this, the blue stuff. This stuff. We want the area of that. And we're given this whole length is 10, and then this is 2. So what that means is we need to find the area of this. Well, this is a parallelogram. Just a circle inside of a parallelogram. The area of a circle is easy. As far as this one goes. We just use pi r squared, and we already have the r. And so we have pi, and the r is given to be 2. And I can do 2 squared in my head. And we get pi 4 or 4 pi. Let's just write it as 4 pi for now. Leave it like that. But then this is a parallelogram. And if you remember, the formula for area of parallelogram is base times height. I've already got the base. That's given to be 10. It's the height I need. But here comes a circle, and I need this height. Well, if this is 2, and then this is going to be 2, and that's going to be 2, which means our height is going to be 4 feet. So that's going to be a 4. See that? I could also do it like this. All the way across is 4, which is the diameter, so the diameter is going to be 4. Vertically also. So no matter how I look at it, my height is 4, because it's the same as the diameter of the circle, which is 40. So the area of the shaded figure, shaded region, is found by using the area of the parallelogram minus the area of the circle. See that? The circle isn't shaded. What that means is I need to get rid of all that. It's got to go. So I'm going to take my 40 and subtract my 4 pi to find the area of the shaded figure only. So this is a subtraction problem at this point. So let's just do 40 minus 4 pi. Wait, gotta be careful with this calculator. 40 minus, I'm going to do parentheses just to be safe. 4 times pi, close parentheses. Yeah, that's how you want to do it. Equals 27 point, let's go two places. 43. And these are feet, and this is area, so it's square feet. Using a graphing calculator, it's a little bit easier. 40 minus 4 pi. You can see it's a lot easier to do that with this calculator. So watch out for those kinds of problems. Use the information that you know about circles and parallelograms, areas, whatever it may be in this case. And the last topic we're going to talk about is the Pythagorean Theorem. This is mainly for triangles. And so let's look at this. We have, first off, the Pythagorean Theorem says if you take the sum of the measures, or sum of the squares of the measures of the sides that are adjacent to the right angle, that's equal to the square of the side opposite the right angle. So the sum of the squares of the sides adjacent to the right angle is equal to the square of the side opposite the right angle. Well, these sides are connected to it, the right angle, are called legs. Doesn't matter which one is A or B. This side opposite the right angle is called the hypotenuse. And that's where those come from. And then if you just use these typical symbols, a squared plus b squared equals c squared, and this is your Pythagorean theorem that most people know how to use. A and b are the legs, c is the hypotenuse. Really easy to use, but it has to be for a right angle, or right triangle. Big deal. Big, big, big deal. Right triangle only. Here's how you use it. We're going to find the missing sides of these right triangles. Well, this side is our C. It's our hypotenuse. So we're going to use a squared plus b squared equals c squared. It does not matter which one you call A or B. If you want to call that one A, call this one B, it's totally fine. If you want to reverse them, that's fine also. So you have 15 squared plus 20 squared equals c squared. We don't know what c is. 15 squared is 225. 20 squared is 400. And then 225 plus 400 is 625. So far, there's nothing major that we've done if you have any math background whatsoever, until we get to this step right here. So I'm going to come over here and write it up here. We don't want c squared, we want c. So what that means is we need to get rid of this square. Did you know that if you see a symbol like this, that's the same as the square root, which means it has a little bitty 2 on the outside. Well, that's used to cancel out an exponent of 2. So you take the square to both sides. That's what we did right there. We took the square to both sides. What happens is this symbol cancels that symbol and leaves a C, and the square of 625, we're going to find out, is probably 25. So using this calculator, first off, let's do these. Make sure 15 squared, and then 20 squared, and then we're going to add that back to the 225. We get the 625. Now this symbol right there is your square root symbol, and we do get 25. So it's 25 centimeters. If you're using graphing calculator, all you would do is you could just do the 15 squared. You just do plus 20 squared if you want to all at once. And it gives you that. And then take the square root of that. Square root's above the x squared key. It's right there. So I did second and then the x squared key to bring up the symbol above it. 625. You get 25 centimeters, and that's your C. Right triangle. Need a missing. You have a missing side. This, make sure you always note the C. So the angle opposite the right angle is called the hypotenuse, which is our C. So that means if we call this one A, this one's going to be B. So we're going to use A squared plus B squared equals C squared. By the way, I'm more comfortable using C squared equals A squared plus B squared, so it doesn't really matter how you write it. And you may be familiar or comfortable using C squared equals A squared plus B squared also. Same thing, doesn't make a difference. So A we call 3, don't lose the square. B we don't know, don't lose the square. C is given to be 20, don't forget the square. 3 squared is 9. 20 squared is 400. And then we have a different situation. We're going to get the B squared by itself, which means we need to get rid of that 9. And that's a positive 9 that's being added. So to get rid of it, or to move it over, you subtract it. You always do the opposite. So we get B squared equals 400 minus 9 is 391. Now I'm going to go up here. And just like we did before, I need to get rid of the exponent. So I'm going to take the square root of both sides. That will cancel, leaving the B. Now square 391 probably doesn't do anything, so that may be the final answer, but we're going to take out our calculator and see what happens. It may be a nice number. I'm hoping that it is. If it's not, we'll have to use a decimal approximation. No big deal. I'm using scientific, 391. Oh, see that? So if it wants an exact answer, I'll leave it as a square root of 391. If it wants a decimal approximation, then I'm going to use 19.77 centimeters. So either one of these answers is correct. If you're using graphing calculator once again, square root of 391. 19.77. And then our last example is a word problem. It says you got a moat surrounding a castle, 18-foot wide moat. And the wall is 24 feet high. And we want to know the ladder. Well, this forms a right angle. Anytime you're asked to find the missing side of a right angle, right triangle, Pythagorean Theorem. No matter what side it is. This side happens to be C again. And so we can call this one A and call that one B. Doesn't matter. We have C squared equals 18 squared plus 24 squared. 18 squared, I think, is 324, but not 100% for sure. So we're going to find out. 18 squared, there it is. Yep, I was right. 24 squared, I don't know that one. 576. So we're going to add those two together. Probably 900. Let's make sure. Always make sure. 576 plus 324. Well, you know. And then solve this square root. And we get C is equal to probably 30 if I had to guess. And what do you know? Square 900 is 30 feet. You need a 30-foot ladder. And that's all.